Hi, I'm Hamilton, doing it the Kiwi way.
Now let's look at our nMOS NAND gate. First we'll draw VDD, got our compulsory resistor, and a NAND is consistent of two nMOSes. Whoops. With two inputs, A and B, and the output Q, represented by this in digital logic, A and B, they're not signed, and Q is the answer here. The truth table, two inputs A and B, and the output Q. 0, 0, 0, 1, 1, 0, and 1, 1. Q is equal to A and B all knotted. So this is false, this is true, this is true, and this is true. So the QN network, we designed it as A and B. And what we do is we've got our Q coming out here. And it'll go into our load. And the LED is on when Q is equal to 1. Now let's go and construct it in Multisim. So quick summary, everything seems to be working now. We've got our two resistors that are required for each switch. We've got switch A and switch B. I'll just change the value of it to B. A little bit more tidier. When both gates are open, we're applying 5 volts at the gate and the LED should be off, which it is. We're in simulation. In any other situation, the LED will remain on. So that looks great. What we'll do is we'll copy and paste that. Both switches open. And a snipping tool. We'll save that. And now we'll, instead of doing it on the breadboard, the virtual breadboard here, I'll go and construct it straight away on the real breadboard.
So what we've got is two nMOSs, 1, 2. We've got a resistor, and we'll use that to use this switch B. And we've got another resistor which we'll use with the nMOSs as per the diagram, and that is resistor R0. So let's get started. I'll probably speed this up to make things a bit less painful for you. Right, if you're with me still, what we've got is these two resistors up here, these two. Then this resistor here is this resistor tucked in the side here. And that's our resistor. That's mandatory for our two CMOSs, which are these two here. We've got our signals A and B. A and B, and our answer Q is this one here. At the moment both switches are open and we're running simulation here, and our breadboard is on, our NI Elvis breadboard is on. So when we press both switches, the light's on. When we close both switches in the simulation, you'll see our LED here is on. When we release the top switch, the LED is still on, and you can see from the diagram here that the LED is still on. When both switches are open, the LED is off, and in the diagram you can see that the LED is off in the simulation. So we've got all that working. That is our nMOS implementation. Ooh, that's a bit of a mouthful. Of the NAND gate.